Welcome back to the second lecture of O-Level Math 4024 Mensuration, and our topic is cylinders. I think everyone remembers that in the last video we talked about closed solid cylinder versus an open cylinder. How was the formula for surface area similar or different? How was the formula for volume similar or different? And our focus in that particular video was understanding the different formulas in complete totality. And we look at the formulas from the perspective of a soup can, which is of course in the form of a cylinder, and from the perspective of units. So now, what is new in this video? In this video, we would be talking about different exam type questions of different levels of difficulty. There are 4 main questions that we are focusing on. And before that, one major thing that troubles the student is the concept of conversion from one unit to the other. So now let's focus on that conversion. So last time we talked about the units from the perspective of that formula, and this time we are talking from the perspective of conversion. Now there are 3 kinds of dimension that we deal with. We deal with the dimension of length, we deal with area, and then with volume. And there are 3 units that we deal with. The first unit is that of meter, the second one is centimeter, and the third one is millimeter. So now this is the thing that happens, that's the relation between them. 1 meter is 100 centimeter. Remember the word centi. Centi means something to do with 100, like centipede. 1 centimeter is 10 millimeter, and the word milli refers to 10. So if I want to convert from meter to centimeter, I multiply by 100. If I want to convert from centimeter to millimeter, I multiply by 10. So remember this rule. Meter to centimeter, multiply by 100. Centimeter to millimeter, multiply by 10. On the way back, millimeter to centimeter, divide by 10. Centimeter to meter, divide by 100. Let's look at the first example for length. I want to convert 5 meter into millimeter. I can do it directly, or I can first convert meter into centimeter, which becomes 500 centimeter, and 500 centimeter therefore becomes 5000 millimeter. Now, what about the way back? If I want to convert from millimeter to centimeter and centimeter to meter, I can take an example of 7000 millimeter divided by 10, make it 700 centimeter, divided by 100, make it 7 meter. So in other words, 7000 millimeter is in fact the same thing as 7 meter. Remember the golden rule that is given over here. So now if I move on and I talk about area, how should I proceed with this? Think about it. The rule in math that is based upon justice is that whatever you do to one side of the equation, you do it to the other side. That means if I have the conversion from meter to centimeter, 1 meter is 100 centimeter. Square both sides. Therefore, 1 meter, the whole thing square, that becomes 100 centimeter, the whole thing square, which is 1 with 4 zeros. So therefore, 10,000 centimeter square. Similarly, 1 centimeter is 10 millimeter. Apply the same procedure. Square both sides. 1 centimeter square is equal to 10 millimeter, the whole thing square. Therefore, 1 centimeter square is 100 millimeter square. Got the idea? Now, what would be the conversion? The conversion would be 1 meter square is 1 with 4 zeros centimeter square. 1 centimeter square is 100 millimeter square. In other words, this time when you have to convert from a meter square into centimeter square, multiply with 4 zeros. When you want to convert from centimeter square to millimeter square, multiply with 2 zeros. That means meter square to millimeter square, multiply that by 6 zeros. Now, when I say 6 zeros, I mean from the concept of simplicity. When you multiply anything by 0, that becomes a 0. What I mean to say is that increase the number of zeros by 6. That is the rule. What's the other way? multiplication, the opposite is division. So millimeter square to centimeter square, division by 100. Centimeter square to meter square, that is division by 1 with 4 zeros. Now let's look at this example. In this example, we have meter square, 4 meter square, that is converted into centimeter square and then converted to millimeter square. In the other example, we are converting millimeter square to centimeter square to meter square. Now this is the concept of division. Let's look at both the examples. Now this thing about area is done. Let's move to volume. The same concept would be applicable. When we were squaring both sides for areas, what should we do for volume? We should cube both sides. So therefore, when we cube both sides, 1 meter cube is 1 with 1, 2, 3, 4, 5, 6 zeros. Similarly, 1 centimeter is 10 millimeter. When we cube both sides, what happens is that 1 centimeter cube is 1 with 1, 2, 3 zeros. Now, what is the rule? Remember this rule at the bottom. Meter cube into centimeter cube, multiply with 1, 1, 2, 3, 4, 5, 6 zeros. Similarly, centimeter cube into millimeter cube, 1 with 3 zeros. On the way back, divided by 1 with 3 zeros. On the way back, divide by 1 with 6 zeros. So remember this rule for length. Remember this for area, and remember the same kind of rule for volume. Now, having said this, let's move to past paper questions because they are our first priority. So the exam questions from different past papers, let's get started with them. Let's read the first question. Now, the question, I have not pasted the whole thing at once because it consists of different parts. Therefore, a part would appear, its solution would appear, and then we move to the second part. Now, this is from November 2012, variant 21, question 7. Tuna chunks are sold in cylindrical tanks. The 130 gram tin cost $1 and 185 gram tin cost $1.50. Which one is a better value for money? Show all your working. Now, this has nothing to do with mensuration. The second part will have to do something with mensuration. But since this has come in our way, there's no harm in solving it. So now there are two approaches for this. What I can do is that I'll apply the ratio method and I'll say 130 grams cost 100 cents. What is the price for 1 gram? Simple ratio, simple division. Now look at my working. What exactly am I doing? I'm writing down the steps. I'm keeping everything ready. And then once everything is ready, then I'll go to my calculator. I'll push in some buttons and I'll write down the answer correct to the desired level of accuracy. 1 gram of the first type is costing me 0.769 cents. The other one is 0.811. This is cost per gram. Which one is cheaper? 0.769 cents. Therefore, the cheaper one in this context is a better value for money. Let's move to the same question but from a different perspective. The same conversion is here. 100 cents is buying me 130 gram. What would 1 cent buy me? So now this is 130 over 100. This is one value. Similarly, 150 cents is buying me 185 grams. 1 cent would buy me 185 over 150. Using a calculator, that gives me 1.23. Therefore, which is a better value for money? For 1 cent, is it better to buy, achieve, obtain 1.3 grams or 1.23? I think 1.3 is better. So therefore, it's a better value for money. Needless to say, the conclusion would be the same. The methodology is different. Over here, 1 cent is buying how many grams? Over in the previous one, what was the cost per gram? So there were two approaches to this particular problem. Now, let's move on. The diagram shows a cylindrical tank, a cylindrical tin. I don't know why I'm saying tank over and over again. It's a closed cylindrical tin. It's 11 centimeter high and the base has a diameter of 7 centimeter. Remember the word diameter. Our formula is based upon radius and not on diameter. So the radius is 3.5. It's your choice to work with fractions. It's your choice to work with decimals. Let's look at the working. Calculate the volume of this tin. So now volume is pi r square h, that's pi into 7 over 2 square into 11. And this time I'm not using decimals, I'm using fraction, simplifying as much as possible till the very last step. So therefore I use the calculator. I plugged in the value of pi as 3.142. Remember, I'm using a 4 significant figure value because the final level of accuracy is 3SF. So I get the answer as 423.38, which after rounding off becomes 423 centimeter cube. And after doing the working, make sure to write the answer where it belongs. Now let me rephrase this question. What if this was an open cylindrical tank? Will the volume change? The volume will not change because closed, open, solid volume is exactly the same. Now let's move to the next part, which is about the surface area. Since it's a closed cylindrical tank, there is a tin, there is a top, there is a bottom, there is a curved surface area. So therefore, area of the top, circle, area of the bottom, circle, area of the curved surface, that is 2 pi r h. Apply the formula, get the answer. It's a simple plug and chug kind of question. I'm working in terms of pi so that I don't have to worry about accuracy in the middle of the steps. I'm working in terms of pi, which you will see on the next page. Let's move on. So 49 pi over 4, 49 pi over 4, and this comes out to be 77 pi. I'll add it all up. The first thing in maths, remember, use common sense to take common. Whenever there is a possibility of taking common, do take common. So I'm taking pi common and then I'll add it up. And of course, I can use a calculator with fractions. It's perfectly allowed. And I can either leave the answer in terms of pi, do that, as well as leave the answer in terms of decimal, of course, to the desired level of accuracy as set by the examiner for this particular paper, which is giving the answer correct to 3 significant figures. So now this question is done. That was about the concept of surface area. Now can you think, how am I going to modify this question? Just like the first one, it was closed, I made it open. It was closed, I'm making it open. So now if it's an open cylinder, what will be missing? The top area would be missing, bottom area would be the same, curved surface area would be the same, everything else would be a simple addition. Remember the rules of maths. Simplicity. Simplicity. Do not apply premature approximation. Work in terms of pi, add it all up and then use a calculator later on. Now, the third part of this question. In addition to the surface area, a closed tin requires an extra 30 centimeter cube of metal to allow the top and bottom and side to be joined together by welding. Calculate the area of metal required for 30,000 closed tins. So it's a simple arithmetic based calculation. You already have the area, but remember one golden rule. If an answer from the first part is being used in a part later on, always use the unrounded value. Unrounded value minimum to 4 significant figures. It could be a little bit more. That's not an issue. So to the answer of part 2, 318.913, add 30 and then simply multiply it with 30,000 because we are talking about 30,000 tins. So when I multiply, this is the weird answer that I get. But now there is a trick. What did we start with at the beginning of this video? We started with the conversion thing. So the answer is coming out to be in centimeters square, but the examiner is asking in terms of square meters. So work everything in terms of centimeters square. Apply the conversion. You can show the working to the examiner. You can impress the examiner with each delicate piece of working. 1 meter is 100 centimeter. 1 meter square is 100 centimeter square. And therefore apply the unitary method and then you get the answer. So the answer comes out to be this thing. And what's the last thing? Take care of the accuracy. And the answer is 1050 centimeters square. So that was this question. And these were the answers. So that was the first question. Let's move on. The second question. The volume of a cone is given for a later part, but that's none of our concern at this moment. And this is the circular, the blue one is that inner cylinder which has been carved out throughout, uniformly carved out. And the capital R, that is the radius of the big cylinder. That would be the small r plus 3.5. Now, I have not actually even looked at the question, but I have a feel of what's going to happen. They're going to ask us whatever that shape is left, a big cylinder minus a small cylinder, calculate the volume of that cylinder. Or maybe the volume is given, they can ask us to find the value of small r. Now, for this purpose, we don't have a separate formula for that shape. That donut shape in 3 dimension, we don't have a formula for that. So what we will do is that we will apply the concept. Let's first look at the question. Solid one is a cylinder with a small cylinder removed from its center as shown in the diagram. Height of each is 20. Radius of small is r. Radius of the large is 3.5 greater than the radius of the small cylinder. And the volume of the solid is this much. Calculate r. Very, very simple. There's a big cylinder and a small cylinder has been carved out of it. Whatever is left, that is the solid. That means the volume of the big cylinder, volume of the smaller cylinder. Of course, needless to say, both will be in terms of R. Let's look at the working. Volume of small, volume of large. And over here, one thing should be taken care of. Let me come to it in a short while. The difference between the two is 3000 centimeters square. The most common mistake that people do is that when they expand something of the form a plus b whole square, they forget the idea that a plus b whole square, what is it? A plus b whole square is a square plus 2ab plus b square. So remember this and you're all set to get an A star. So therefore, when you open up the bracket, be very, very careful. I have kept pi as it is. I am in no hurry to tell the examiner that I know the value of pi is 3.142. Simplify, simplify, simplify. Keep r till the very end. Keep pi intact. And when you have reached the stage, you have made r the subject of the formula. Now it's time for your calculator to be used. Use the calculator and then you get the answer. Take care of the accuracy. And that is the answer. So the second question is also done. Let's move to the third question. The third question is, a cylindrical candle has a height of 5 centimeter. A is the center of the top of the candle and B is the center of the base of the candle. Make a habit of reading a line and then looking at the diagram. So I read this much. I look at the diagram. I see 5 centimeter. I see A. I see B. And then I see a 12 millimeter. Centimeter, millimeter. Keep that in mind. There is a wick. That small thread in the middle of the candle, that's called a wick. The wick runs through from B through A and extends 12 millimeters above A. How many of these candles can be made using a 2 meter length of wick? Now the examiner is very clever. There is meter and centimeter and millimeter in it. Take care of it. Look at the working. 5 centimeter is 50 millimeter. Length of wick is 12 millimeter plus 50 millimeter. And 2 meters is 2000 millimeters. So I got everything in terms of millimeters. Now, somebody could ask this question, why not everything in meters? Of course, there is a possibility. Tell me one thing, is it easier to work with decimals or is it easier to work with lot of zeros on the right hand side? I think it's always easier to work in a unit in which you avoid decimals as much as possible. So 2 millimeter is 2000 millimeter. It's a simple division question. You get this answer in fraction. You can also write in decimals. We are simply worried about the quotient, which is 32. Everything else is a wastage. That means 32 full candles can be made in this scenario. 32 wicks can be made for 32 different candles in this particular scenario. Now, this is what the examiner is saying. Candidates needed to divide the total length of the wick by the length in each candle and then to round down to an integer. Several had difficulty. Understand this. Several had difficulty adding 12 millimeter to 5 centimeter. However, although a method mark was still available. Now, the main purpose of reading out these small segments from the examiner report where necessary is to emphasize to the examiner that when a teacher is emphasizing on conversion of units, there is something important. The teacher does not want you to lose these marks and thus falling from grace, falling from an A star to an A, or falling from an A to a B, and something like that. So now let's move on. The second part. The wick is in the form of a solid cylinder. The volume of the wick inside the candle from A to B is 0.2 centimeter cube. Calculate the radius of the wick. Now, this question, I can do it in two ways. In the first method, I am working in which particular unit? I am working in centimeters. Height is 5 centimeter, radius is unknown, volume is 0.2 centimeter cube. I'll get my radius in terms of centimeter and then later on I can convert it into millimeters. So again, I made R the subject of the equation. I'll use a calculator. I won't forget to take the square root sign. I get the answer as 0.1128. I round it off, but 0.113 centimeter is 1.13 millimeter. Just take care of that. This is one approach. Another approach, work in millimeters from the beginning. That means convert 0.2 centimeter cube to something millimeter cube. Now, I have shown you both the methods. Let's look at this one first. That's the conversion in cube. So 0.2 centimeter cube is 0.2 into 1000, which is 200 millimeter cube. Volume is this much. Height is 550 millimeters. And then you find the value of R. So the value of R, of course, will come out to be the same thing as 1.13 millimeter. Now, in this one, you did the conversion at the beginning. You don't have to do it at the end. Now, whichever one you find it easier, just work with that. I think method one, in my view, is easier. The second one could be thought of as a bit lengthy because you had to play with the length into the volume thingy. Now, let's move on. Now, look at the third part. This is again the first part and this is the second part B. One candle was made by pouring candle wax into the cylindrical mold so that it surrounded the wick. The mold has an internal radius of 1.9 centimeter. Calculate the volume of candle wicks required to make this candle. That means this is just like the first question that we started with, first or the second one. That has a big cylinder on the outside. A small cylinder has been carved out, something like this. So in this one, that carved out portion is actually the volume of that wick. Calculate the volume of the candle required. Now this is 1.9 centimeter. Volume of candle is pi r square into h. That's the full volume. That is written in terms of pi I've written. I'll plug in pi later on. Volume of wick is this much. Therefore, volume of wax. That candle is made up of wax and wick. So the whole cylinder is 8.05 pi. From it, subtract the carved out portion, the wick. What do you get? The volume of wicks. So therefore, this is 18.05 minus 0.2. Use a calculator. And of course, wick is just a very small portion. It's all about the wax. That comes out to be 56.5 centimeter cube. That is the volume of candle required. Now, what does the examiner report says? The majority of candidates were able to find the total volume of each, but many of these did not subtract the volume of the wick. They forgot. It was easier to use the given 0.2 centimeter cube rather than to work it out using the answer of the last part. Okay. So now, how many of these candles can be made using 3 liters of candle wicks? Okay. 1 liter is 1000 centimeter cube. 3 liter is 3000 centimeter cube. So it's a simple division question. 3000 divided by 56.51, the unrounded value. 53 point something. Again, use the quotient, use the integer value. So 53. If it is worth 53.08 or 53.98, we only would focus on the integer because everything else is wastage, because that cannot be converted into a single candle. That is the reason. So it's not a matter of rounding up. It's always a matter of taking the integer out. So 53 candles can be made. Candidates were expected to divide 3000 by the previous answer, rounding down to the nearest integer. Working was followed through strictly. So if the answer to the previous part was wrongly left as 56.7, then the answer to this part should be 52. Then it's up to the examiner to give the follow through mark. That is called error carry forward. That is something else. Let's move on. The last part. One of these candles is placed on a rectangular piece of wrapping paper. The paper is wrapped around the candle so that it covers the outside, and there is an extra 1 centimeter for overlap. What length in centimeter of paper is required to wrap one candle? So the working is, we would add this extra 1 centimeter later on. Curve surface area, you might think that is needed, but no, we are only looking at the length. So be very, very careful for such small questions. That was some common misconception of curved surface area. Basically, we want the circumference of the circle. So 2 into pi into r, which is 1.9. That comes out to be 11.94 centimeter. Add 1 to it. That's 12.94 centimeter. Round it off to the desired level of accuracy, which is 3SF. And that finishes this question. The length required is 1 centimeter more than the circumference of the base of the candle, but many did try to use the area of the base. Exactly what I told you before. And that finishes this question. That is the whole section from the examiner report. Of course, once you have done the video, you have looked through it thoroughly. Of course, you can read it. And that is the answer over here. And that finishes the second lecture on the concept of cylinder. I hope that you have understood everything, anything to do with surface area and volume of a closed cylinder, open cylinder, solid cylinder, and how these formulas came into being. If you are having any difficulty with these 4 questions, then it means that go to the first video and understand the concept before you go through these 4 questions and many more questions that are given in the past paper. So that's the bottom line of the story. Take care.